Okay, logic fans, we are going to do this same disjunctive elimination we did before. If you've seen this video already, please watch it again. And if you haven't seen it, please watch it carefully. In either case, pause right now and grab a sheet of paper so you can do this with me. Please just pause and grab a sheet of paper. Trust me, people are still getting this wrong. I've graded all the midterms now, and I can see that people are still not getting disjunctive elimination. So I want to do it one more time, a little bit more quickly, hopefully even more clearly if that's possible. I tried to make it clear last time, but I want to make it very clear, and I also want to make it clear what things you cannot do that people are still trying to do. So these are the assumptions I've got. And remember, what I'm trying to do here is just show you that you have an intuitive understanding of what it would mean to work with a disjunction elimination. It's something that you understand. It's not such a weird concept. And you've probably done this thousands of times in your own life, but you just never realized it. And you have to be able to do it according to the formalism of SD. And there's another thing I want you to please pay attention to. This advice we've given you, where we say, hey, if you've got a disjunct, that's what this thing right here is, this wedge. This sentence means L or S, and the way we've been thinking about it informally is that it means I'm either going to go out with Leah or Sophia. I'm not allowed to. I'm not saying which one it is. I don't have any sure assertion here that I'm definitely going out with Leah. And there's no assertion that I'm definitely going out with Sophia. It's just that I'm going to go out with one of the two. I'm going to have a date with one of the two of them this weekend. And so this disjunction, in SD, you typically better be prepared to do a disjunction elimination. Now in SD+, that's not the case. Some people were trying to do, on the SD+ proofs, it's true that you can use SD rules. We've told you that. And some of you, you use them maybe because you're afraid of the SD Plus rules, but the SD Plus rules are your friends. They make the proof so much shorter. If you take a look at my video on the SD Plus proof, you can see that it's doable in 5 steps. And some of you were taking so many steps because you wouldn't just take a careful look at those SD Plus rules. And they're really easy. There they are. And all you have to do is, if you had a wedge, you just look here and see, well, what are the things that involve wedges? Well, there's commutation. That's got a wedge in it. Association, that might have helped. Well, here's a good one. And this is a point I made whenever I made the video for that, is that if I've got a wedge, I can convert it to a horseshoe, a conditional. And if I've got a conditional or a horseshoe, I can convert it to a wedge. That's a super powerful rule. It's very powerful. And you can't do that in SD. And you just want to keep in mind that if someone's making an exam for you, they probably, and you know, some of the proofs are SD, some of them are SD+. What do you think? Do you think that they're going to throw some maneuvers in there for SD+ and an SD+ proof? Of course they are. And it's going to make your life easy, so use them. But in an SD proof, restricted rules, there's nothing else you can do with this. When you've got one of these, how do I know? Well, I just check the rules. I look here, wedge rules. There are only 2 of them. I can introduce one. Well, I don't need to do that. I already got one. That's the problem. There is a wedge. I have to work with it. And so what happens if I've already got one? Well, I have to do this thing called a disjunction, there it is, disjunction elimination. And how does it work? Well, it works like this. I tell you, I'm going out on a date with Leah or Sophia, and I just imagine each one of those dates and try to show you that no matter which date happens, I end up going to a movie. Derive M. We tell you the basic advice is that if your main strategy is a disjunctive elimination, try to go for the goal in each of those disjuncts. So I imagine then, what it would be like to go out with Sophia. That's the same thing as just assume Leah, pardon me. Assume I go out with Leah. I just imagine that date, and I try to show you that it's going to end up with me going to the movie. And then I do the same thing with my date with Sophia. Well, imagine I go out with Sophia instead. I'm not saying which person I'm going out with, because there's no such assertion here so far that I can see. It's just maybe it's either Leah or it's Sophia. But it doesn't say for sure which one it is. If it just said, well, you're going out with Leah, well, okay, easier proof. But it doesn't say that. So I have to imagine each possibility and try to show that it gets me to the same endpoint, which is a movie. So if I could show that, I imagine my date with Leah, oh, look, it turns out I'll go to a movie. I imagine my date with Sophia, oh, look, ends up we go to a movie. well then I would be able to just eliminate this sentence here, and because I would have shown you that, well, no matter which of these happens, it's a movie, so I may as well just get to write movie here. You see, that's what this thing ends up entailing by the time once I work with these other premises, of course. So taken together, these premises will entail M. Now, one of the things that you keep trying to do, a lot of you, so please pay attention to this. Let's say my only premise is L then M, and someone asks me to derive M. I can't do it. The answer is I can't do it. We're done. Someone says, okay, assume that if you were to go out with Leah, you'd take her to a movie. So prove that you're going to a movie this weekend. I say, well, I can't prove that because I don't know that I'm going out with Leah. Nobody says, there's no such assumption there. Some of you, given this premise, you tried to just write L, and you called that a conditional elimination. But there's no such thing. When I take a look at the rule for conditional elimination, here are the rules for horseshoes, for conditionals. Sorry about that. This will focus in a second, I'm sure. I see conditional elimination, and it says that I have to find the P somewhere. It doesn't say that I just get to randomly write it. So I know that might seem a little confusing. It says you have a conditional somewhere, and then you have the thing that gets in the front. We call that the antecedent. That means that you get to write down the thing in the back, the consequent. But you can't just write it yourself. This is not meant to imply that when I've got a conditional, then I write this, and then I write this, and I have conditional elimination. No, that doesn't function. That's illegal. It doesn't. Don't ever do it. Never. Never do that. Never, never, never do that. Another situation some people are doing is they're writing M, and they're calling that conditional elimination. No, that's not legal either. The only way I can eliminate this conditional is if there were another premise now I can write M. That's legal now. So that's a conditional elimination, and I know it's got two parts. It's got the conditional itself, then the antecedent, the thing that comes before, and then I can write that I eliminated conditional. And all of you know this. You're saying, I say to you, if I go out with Leah, then I'm going to go to the movies. So therefore I'm going to the movies. You would say to me, well, so are you telling me you're going out with Leah? Because you just said if you're going out with Leah, then you're going to the movies. How do you can just conclude that you're going to the movies? That just makes sense to you. I tell you, if you get an A in the course, then I take you out to dinner. And you say, okay, well, let's go out to dinner. I say, you didn't finish the course. You couldn't possibly have gotten an A yet. We don't know you have an A, so we can't just conclude that. You might say to me, well, all right, here's what you're telling me, Nikos. You say, if I get an A in the course, then you'll take me out to dinner. So let's assume that I get an A in the course, and let's call that an assumption for conditional elimination. There's no such thing. There's no such thing as an assumption for conditional elimination, because if I said to you, if you get an A in the course, then I take you out to dinner, and you said, okay, well, let's just assume that I got an A, and then we'll go out to dinner, I would say, no, that's not what I said. That would be nice. That would be a fun idea, but it doesn't function. So you cannot ever, and you know, there's another reason, and that is, I can just look here at the rule, and it doesn't have an assumption. You see, it doesn't have one of these lines here that indicates I can make an assumption. So not only do you understand this, I know you understand that you can't just eliminate conditionals, but you can, even if you didn't, if you said, no, I don't understand that, I would tell you, well, there's no assumption line here. But there is an assumption line in the wedge elimination. You see there are two of them, where I take P, and then I take Q, and I assume each one in turn, and I show you that it leads to the same result. And so therefore, I show you that's what I can rely on, that I've got that result, because whether it's P or it's Q, it ends up with this result R. And over here, I'm trying to do the same thing. I tell you I'm going out with Leah or Sophia. I imagine my date with Leah. I show you that it ends in a movie. I imagine my date with Sophia. I show you it ends in a movie. Therefore, I get to tell you, hey, I'm going to a movie. We can all agree. So here, because this is a legal assumption, because I get to write here assumption for disjunctive elimination for each one of these, I can now use these assumptions for whatever I derive underneath them. But in each of these cases, what happens in my date with Leah stays in my date with Leah. What happens in my date with Sophia stays in the date with Sophia. This is Vegas, this is Bangkok. What happens in Vegas stays in Vegas. What happens in Bangkok stays in Bangkok. I cannot take L and write it down here. I can't take the M that I concluded and just write it down here and cite that, hey, well, I concluded it up here. No, I concluded it based on imagining a date with Leah. So when I imagine a date with Leah, that's the date I have to stay on. And whatever happens, if there's anything that I can logically conclude, well, that's fine. That's part of the date with Leah. Then I imagine my date with Sophia. Whatever happens, if I can logically conclude it, okay, that's fine. That's what's going to happen on that date. But I cannot mix and match. Got it? Always remember, what happens in Vegas stays in Vegas. What happens in Bangkok stays in Bangkok. Never the twain shall meet. They're in different worlds. So, once I assume, though, that I'm going out with Leah, that's now, I can validly access that in combination with these other premises as long as I keep it within this imagined date. And I know that this says, if you go out with Leah, you should go to the movies. If you go out with Leah, then go to the movies. Leah, then movie. That's what the horseshoe indicates here. If Leah, then movie. Well, I just assumed Leah. That's what I just did. And that means, well, under that assumption, my goodness, okay, then you're going to a movie. But I couldn't just assume it because I wanted. You understand? This happened because I was just imagining these two dates. These are disjunctive eliminations. Disjunctive elimination is always a pair because it's always two possibilities, this or that. And I find out what happens by imagining each one. So this was very easy. If I imagine going out with Leah, I get a movie because 2, 5. So please do this proof with me. 2, 5. Conditional elimination. So there it is. I match that exactly. You see that conditional elimination? It has 2 lines to it. One line, the conditional itself. One line is the antecedent. Then I get to write the conclusion at the end. One line is the conditional itself, pardon me, a little ink stain there. One line is the conditional itself. The next one is the antecedent, the part in front. And I legally made that assumption. Legal. That was a legal assumption. And having made that, I get to conclude M. Then I assume Sophia. So on my date with Leah, I realize I'm going to a movie. Now that's line 6. On my date with Sophia. Well, if I go out with Sophia, I know I'm going out with someone who doesn't get to see movies very often. So I just assumed I'm going out with Sophia. What I conclude is that I'm going out with someone who doesn't get to see movies very often. So this is line 7. This is line 8. And how did I know that? Well, again, this says if you go out with Sophia, by the way, you'll be going out with someone who doesn't go to see movies very often. And I say, oh, well, I just assumed I'm going out with Sophia legally because it's a disjunctive elimination. And so that means I can conclude by means of 3 and 7. That is a legal conditional elimination. Now, I found out if you go out with someone who doesn't get to see movies very often, then take them to a movie. I just found out that I'm going out with someone who doesn't get to see movies very often, so I can take them to a movie. So this is line 9, and that's using 4 and 8, and that's a legal conditional elimination. Sorry, so there. And now finally what I know is based on 5 and 6, that was imagining my date with Leah, and then based on 7 through 9, that was imagining my date with Sophia, I know that I'm going to a movie. Pardon me, I know that I'm going to a movie, that's what I just wrote there. And I know that based on disjunctive elimination. I apologize for the fudge there. Okay, so that's the situation. Keep in mind that you cannot eliminate conditionals in these magic of Disney ways. It would be really great if I could just eliminate this conditional and write M and I'd be done. You know, here I've got these 4 whole premises, and then I just say, well, it's okay. M, conditional elimination on line 2. No, that doesn't work. Well, L then, that's conditional elimination. No, that's not either. You can't get M unless, given these premises and an SD, unless you go through this whole process. That's just the way it goes. Do not ever tell me that you have made an assumption for conditional elimination. It doesn't exist. Look at the rule book and you'll see there's no such thing. When I look at conditional elimination, there are no assumptions. When I look at conditional introduction, there's an assumption. That's fine. But I don't need to introduce a conditional. Why? That's not my goal. My goal is not to introduce a conditional. And introducing a conditional is not going to help me in this case. That's not going to function. I see that there are other places where I introduce assumptions. This one, disjunctive elimination, the one I used, I have to introduce two assumptions. First, the left disjunct, this thing, then the right disjunct. And I have to get the same result. Okay, I know this seems like very repetitive and like, you're driving me crazy with this. But people are still making this mistake, and yet it really is straightforward. If you have any questions about disjunctive elimination, about conditional elimination, about anything on the midterm, please ask in next section or during office hours. It's really important that we clear up some of these basic misunderstandings that people are having. I really don't want to see you struggling, because a lot of the things you're struggling with, I know that you can do yourself. That's the part that's so crazy, that given some of the mistakes you make on the proofs, it would be as if you couldn't cross the street or you couldn't go to the grocery store. But you can do those things. And really, we're dealing with a lot of these problems are really at that level where it's just that you're getting in your own way. And I know what that's like. I make lots of mistakes myself too when I do proofs, when I do translations. We all make mistakes. But the basic mistakes I think you can avoid. And that will just incredibly improve your score. You have no idea how some of you, with just a little bit of fine-tuning, if you could just stop making basic mistakes, your score would, in some cases, your score would double. A lot of you would have gotten 20, 30 points higher easily on the midterm if you had just avoided some of these basic mistakes, which I tried to go over in section, and I'm posting here again in this revised version of the Leah and Sophia disjunctive elimination proof. This is all like, it's like, oh, it's a mess. Even though it's a very simple proof, 9 steps and we're there. I hope you understand it. I hope this makes it clearer.